A world that should be dead, but isn't. In the outer reaches of our solar system, far beyond Earth, there is a frozen world. No sunlight, no atmosphere, no warmth. At first glance, it looks completely lifeless. This is Europa, one of the many moons of Jupiter. But beneath Europa's cracked icy surface lies something extraordinary. An ocean, not a small one, an ocean that may contain more water than all of Earth's oceans combined. And that discovery changed everything scientists thought about where life might exist. Europa is no longer just a moon. It is one of the most promising places to search for life beyond Earth. But how can life exist so far from the sun? What is really hiding beneath Europa's ice? And how close are we to finding answers? To understand that, we must travel into darkness and pressure and an alien ocean that has never seen sunlight. Europa, a moon that should be frozen solid. Europa orbits Jupiter at a distance so far from the sun that surface temperatures drop below -160 degrees Celsius. By all normal logic, it should be a dead, frozen rock. But Europa behaves differently. A surface that keeps breaking. High-resolution images show Europa's surface is crisscrossed with cracks, ridges, and chaotic terrain. Unlike the Moon or Mars, Europa has very few impact craters. That means its surface is constantly renewing itself. Something below is reshaping it. Tidal heating, Jupiter's hidden power. Europa survives because of Jupiter. Jupiter's massive gravity stretches and squeezes Europa as it orbits. This constant flexing creates tidal heating. Friction inside Europa generates heat, enough heat to keep a global ocean liquid beneath kilometers of ice. Europa is frozen on the outside, but active on the inside. The ocean beneath the ice. Scientists believe Europa's ice shell may be 10 to 25 kilometers thick. Below that, a global saltwater ocean up to 100 kilometers deep. This is not speculation. It's supported by magnetic field measurements, surface chemistry, and gravity data. Why water alone is not enough. Water is essential for life, but life also needs energy, chemistry, and stability. Europa appears to have all three. Chemical ingredients from space and rock. Europa's surface contains oxygen compounds, salts, and carbon-based molecules. Cracks in the ice may allow surface chemicals to mix with the ocean below. Meanwhile, the ocean likely interacts with a rocky seafloor. On Earth, that combination produces life, especially around hydrothermal vents. Why Europa is a prime candidate for life. Life on Earth did not require sunlight at first. It began in darkness, at the bottom of the ocean, powered by chemical energy. Earth's deep sea analogy. On Earth, hydrothermal vents host ecosystems without sunlight. Life feeds on heat, chemistry, and mineral reactions. Europa's ocean may host similar environments. If life can exist there, it changes our understanding of biology itself. Life would not be rare, it would be cosmic. Signs Europa might be active today. Hubble observations suggest Europa occasionally releases water plumes into space. If true, these plumes could allow scientists to sample the ocean without drilling. A natural window into an alien sea. NASA's mission to Europa. To answer these questions, NASA is launching a dedicated mission. The Europa Clipper. The Europa Clipper will orbit Jupiter and perform dozens of flybys of Europa. Its goals: measure ice thickness, analyze surface chemistry, search for plumes, map potential landing sites,
It will not search directly for life. Instead, it will determine if Europa is habitable. That distinction matters, because confirming habitability is the step before discovery. Why this mission is historic? Europa Clipper is not just a spacecraft. It's a test of a new idea, that life may exist in oceans beyond Earth. If Europa is habitable, then many other icy moons may be as well. What discovery would mean for humanity? Finding life on Europa would not just be a scientific event, it would be a philosophical one. Life would no longer be unique to Earth. It would mean biology is resilient, life finds a way, the universe may be alive with possibility. Even finding simple microbes would rewrite textbooks, because once life begins, evolution follows. The bigger question: Europa forces us to rethink where life belongs, not just on warm planets, but in cold, dark oceans, heated from within. Life may not need a star, just energy and time.
An ocean waiting in the dark. Europa has no cities, no forests, no skies, but it may have something far more important: a second place where life learned to exist, hidden beneath ice, protected from radiation, waiting. For the first time in history, humanity has the technology to look inside an alien ocean. What we find there may answer a question as old as consciousness itself. Are we alone? Or was life never meant to be rare at all?